So the agenda of this presentation is we want to tell you the background of this work, why we are doing this, what are the ultimate goals, even if you're not there yet, where we hope to go. We want to tell you about the autoscaling policy and preferences framework. It's a very powerful engine that's being built inside Solr, and you'll see a lot of exciting stuff happening in future releases. I will tell you about the Autoscaling API, which lets you use this framework, and I'll briefly go over some of the future directions of this work. So the overall goal that we started with, and this is something that Trey has alluded in one of his presentations, I think, is we want to autoscale a Solr cluster to 1 trillion documents and beyond without human intervention. Now, this is a very audacious goal, and there are many parts to achieving this. One of them is autoscaling. The other part is investing in performance and benchmarking, figuring out the bottlenecks, fixing them. It's an iterative process. We're not going to get there in a month or so, but that is the hope, that is where we want to go. So it's not like Solr does not scale to 1 trillion documents already. I know of multiple clusters who have more than 1 trillion documents. Some have tens of trillion documents, but it takes a team to get there. It takes a lot of work to get there. It takes a lot of learnings, some hard fought to get there. But we want this to be possible without having a large team of experts, continuously running and monitoring this cluster. We want people who do not, maybe a team of 2 or 3 people actually to get Solr to that place if possible. So to get there, from an autoscaling perspective, there are 4 problems that we need to solve. The first one is, what should the desired state of a cluster be like? If my cluster is to be stable and performant, what should it look like? How should the cluster layout be? How do I measure the load on the nodes? How do I distribute it, et cetera, et cetera? The second is, how do we measure the current or perhaps the projected state of the cluster? So how do we know that, hey, probably we're going to run out of disk space in 2 days unless we take some action right now, things like that. The third one is, what operations should we do right now to move to a desired state from the current state? Maybe that involves adding a replica. Maybe that involves moving a replica from one node to another. Maybe that involves splitting a shard, and so on. And then the fourth question is, when do we perform those actions? We can do it continuously. We can do it in response to a stimuli, a cluster event, a node joining the cluster, going away from the cluster, free disk falling below a certain threshold, and things like that. So the ideal cluster, there are some things which are kind of always apply. Again, this is not of course, black and white, but usually you want to rearrange the replicas or the collections so that the load on the nodes is balanced. You want it to be stable at all times, even when you're making changes. You want your performance to be first class. You obviously don't want it to go out of disk space. And then other things depend on the use case for which you're using Solr. Maybe your SLAs involve, I want to handle this many queries per second within this, within 100 milliseconds at the 99 percentile times, and so on and so forth. So the first problem is, how do we describe the ideal cluster? So we must describe the layout of the cluster as well as the characteristics. So that might be something like, all replicas must always be on unique nodes, because maybe I do have too much query and indexing traffic. I don't want 2 replicas sharing the same hardware. Maybe you want it to only apply on particular shards. Say, hey, don't put more than 2 replicas of the same shard on the same node. And this is basically like a very, it's like a very stupid thing to do. You shouldn't do that ever. Then maybe you have some more advanced things. Maybe you want to say, hey, all replicas of a particular shard should always go on this rack, but all replicas of that shard should go on that other rack, and so on and so forth. So how do we describe this? How do we tell something like this to Solr? The other part is, how do you measure the load on a particular node? On what parameters do you measure it? So those parameters could be the system load average. It could be free disk space. It's usually a combination of all of them, right? So let's start with what is going to be released in Solr 7. So the work that I'm going to describe is all committed. It's all done. And Solr 7 should be out probably by early next week. And what I'm going to describe right now is what is already available, is going to be available with Solr 7. So the first part, this is the answer to the first question, how do you describe an ideal cluster, is where the autoscaling policy and preferences come into the picture. So the autoscaling policy describes the layout, the desired layout of the cluster. It tells you how to place the replicas and where. And the preferences tell you how do I measure the load on each node, so that you have, at any given time, you can know, hey, which is my most loaded node in the cluster, which is my least loaded node in the cluster. And that information can help you figure out how do you rebalance it. So both of them are specified using a JSON-based configuration. The policies are at the cluster level, so they apply to all the collections, but there is a way to specify additional policies which only apply to certain collections. The preferences, they cannot be added on a collection level. They are at the cluster level, because we're talking about nodes. We don't really care that much about collections right now. If you're familiar with the old rule-based replica placement, there was a kind of a terse syntax, again JSON-based syntax, which you could specify, and you could use that to place replicas in different places. So this kind of, it's a superset of that. So we have changed a few things in the syntax, as well as how things actually work. And I'm going to take you through this in a minute. So let's first look at the preferences. So the preferences is basically about, you can either choose to maximize or minimize a given parameter. And you can have multiples of those. So you can, for example, say, I want to minimize the number of cores per node in the cluster. I want to maximize the free disk on a particular node in the cluster. This naturally tells you an ordering of nodes. So at any given time, if you have functions like this, so first of all, some functions don't even make sense. Like, you would probably never want to minimize the free disk. You want to maximize it always. And these are also not hard conditions, right? For example, Solr can say, hey, you want to maximize the free disk space? I'm not going to add any replicas. There, done, right? You don't want to do that. So this gives you an ordering of the nodes according to the load, and also serves as a goal for the system to achieve. So a preference in the syntax, JSON syntax, looks something like this. You can say, I want to minimize cores. Here, cores actually means the number of cores per node or on a given node. You want to minimize the free disk, system load average, heap usage. There are basically 4 parameters that are supported today. Now, there's something called a precision here. Why do we need a precision? What purpose does it serve? So if you look at the second one, you want to minimize free disk. Now, 2 nodes most likely will never have exactly the same free disk. So if you're sorting on multiple criteria, you're going to stop at free disk, because no nodes are going to be equal. So you're not even going to look at the other parameters that follow it. So in order to create an artificial tie, you use precision. So precision in this case, in the third example, it tells you that, hey, if 2 nodes have free disk space within 50 gigabytes of each other, just treat them the same and go to the next preference in the list. Okay. The policy has 2 parts. The policy can actually, it's like a rule basically. It either applies to a node or it applies to a collection shard replica combination. So in case of a node, you can say, hey, no node should have more than 5 Solr cores. And that is specified by the first example here. Or you can say, try not to have more than 5 cores in a node, but if I absolutely need to add a replica or move a replica, then relax that restriction. Okay? But only if you can, if you can help it, don't do that. The second part is when it applies to a collection shard replica combination. In the first example, we are saying that, hey, all replicas must be on unique nodes for this particular collection. So it says on any node, for this collection, the number of replicas should be less than 2, which basically means 1 replica, or maybe 0 replicas, right? In the second example, we are saying do not place more than 1 replica of the same shard on the same node, right? Because that would be stupid. We don't want to do that. And some of these examples are actually something which Solr already does today, but it is kind of hard-coded into the add replica or the create collection APIs. It's not something that you can change or configure today. Solr already tries to minimize the number of cores. Solr already tries as much as possible to avoid placing replicas of the same shard on the same node. But this makes it more explicit. This gives the control back to the users on how do they actually want to place it. A few more examples. So in this case, we are saying all replicas must be on nodes with more than 100 gigabytes of free space. Now, there are some problems with this syntax. It's not, it's like there are some situations where you have to go to the negative condition in order to specify it. This is something that we intend to fix in later versions, but for now, this is what it is. So in this case, we flip the condition around and we say, on any node which has free disk less than 100, there should be 0 replicas, right? And so on. So you can use system properties. You can use portions of IP addresses to signify, DC or rack and stuff like that. You can do system load average, free disk space. All those parameters are available. And in future, we will expose almost all the metrics that are today exposed by the metrics API, and you can use them inside these policies to place replicas. So that will make it extremely powerful. You don't have to wait on us to add support for parameters. If there's a metric already exposed by Solr, you can use it. Now, there are some gotchas to it. I'll get to it in a moment, but let's continue to the other parts for now. So this is what the policy looks like, and you saw what a preference looks like. Let's look at the API on how do you add or remove these policies and preferences. So there is a new /autoscaling endpoint available in Solr 7. This is an example of the V2 API, in case you're familiar. There's a new API being added to Solr, with a proper syntax. It's basically a more beautiful version of the existing API, which has accumulated a lot of craft over the years. So in this case, you're saying set the cluster policy, and these are the 2 policy rules that you're applying. So as you see, you can add as many rules as you want. If you want to add preferences on the cluster level, this is how you do it. You say set cluster preferences. If you want to remove all the preferences, you just specify an empty array, and it removes all the existing preferences. So this is the write part. What about the read part? So if you just invoke /autoscaling directly, you get back all the policies and preferences that have been added. There are a little bit more to this API. There's a set policy which lets you add policies on a collection level. We're not going to get into that right now because there's a lot of things to cover, and we want to just focus on the most important concepts right now. Now, another API that is available in Solr 7 is the /autoscaling/diagnostics. And what it tells you is, according to the current preferences, it returns the most loaded to least loaded list of nodes in the cluster. So this gives you an idea of which nodes are probably more loaded versus less loaded. It helps you experiment with your preferences and see how it affects, how it might affect the autoscaling operations. So this example was taken from my laptop. So obviously, the free disk is exactly the same IP address. The cores, because I use the example, so it has the 2 cores. But if you did have more cores than less cores, then you would see that in the sorted order. So this is about the desired state of the system. How do you measure the actual state of the system? And so this is actually one of the reasons why we built the metrics API. Of course, exposing metrics is great, but we did a lot of work on the metrics API, especially because we wanted to use those metrics when we were building autoscaling. So the metrics API, if you haven't seen Andre's talk yesterday, it returns almost 250 different metric properties. It also aggregates certain metrics on the shard level and on the cluster level. So almost every parameter that you see in the policy and preferences, the values for that come from the metrics API. Now, this is about the actual state, but when to actually take these autoscaling actions, when to place these replicas. So in 7.0, the support for that is fairly limited. We have support in the collection APIs only, which means that whenever you do a create collection or add replica or split shard or restore collection, we automatically use the preferences and policy to place the replicas in the right places. So if you notice, the auto part of autoscaling is kind of missing here because you're only doing this on API invocations. There are some gotchas here, like for example, for split shard, if you split a shard, the leaders for the new subshards have to be on the same node as the old shard. This is a limitation of the way the Lucene split works today. In future, we can actually fix this to move the leaders around, but at least the replicas of those subshards will be created on the right nodes according to the policies. So just to recap, in Solr 7, we have a new autoscaling policy and preferences framework. It's an engine which computes it. It's also an engine which gathers all these metrics. And of course, there's a JSON-based DSL to specify it. We have a new write APIs to set the cluster policies, to set collection level policies, and to set cluster preferences. We have read APIs for this configuration as well as for diagnostics. And then we have integration with all the collection APIs to actually use this automatically. Now let's go to the more exciting part. Let's talk about what is coming in 7.1. And most of what that I'm going to talk about for 7.1 is something which has, most of it is already been built and committed to a branch in Solr. So it's not like I'm talking of like out of thin air. It's work that we have, most of the work has already been done. And where it has not been done, I'll tell you about it. So as I said, the auto part of the autoscaling was missing. And that's what we wanted to get right, and which is why we made a decision to defer that part from 7.0 because it just wasn't that ready when the 7.0 release branches were being cut. So autoscaling triggers. So triggers are basically you watch a metric or you watch for a certain event and you do something in response to that event. So once a trigger is activated, we evaluate the current state of the system against the current policy and preferences. We figure out what operations should be performed to get from here to the desired state, and then we actually execute those operations. Most of the things here are pretty configurable. If you only want Solr to tell you, hey, maybe you should perform these operations, but you don't want Solr to automatically do anything, you have the option of doing that. So again, it depends on how comfortable you are with this. Maybe you want to try it a little bit before you actually trust Solr to do things automatically. So all those things are possible in this framework. So we have two new triggers. They are very simple. They are based on cluster events. Whenever a node goes away or whenever a new node joins the cluster, this trigger fires, and we evaluate the policy and preferences, and we do certain operations based on that. In the future, we have plans to add triggers based on schedule. So you can say, hey, every night between, say, 2 a.m. to 3 a.m., when I have the least traffic, do something, and stuff like that. Or we can have triggers based on monitored metrics. So you can say, whenever the free disk goes less than a certain point, maybe move out some replicas from this node to that node, and stuff like that. This is how you create a trigger. Again, this is the same autoscaling API, but we have a new command which says SetTrigger. You have a trigger name. You have the event on which you want to listen. Right now, there are two supported events, node lost and node added. And then you have a parameter which says wait for. This is an optional parameter, but it's a recommended one because sometimes what happens due to a large garbage collection pause or something, a node might, for a very brief period, go away from the cluster and then come back. And you don't want these events to be firing. You don't want to start moving or adding replicas based on that. You actually wait for things to stabilize before doing something about it. So this is for the node loss trigger. Very similar to that, we have the node added trigger. There are more parameters which are supported for this command. I'm not including them just for the sake of brevity here. But you can actually customize the list of actions that are performed in response to these events. But by default, the list of actions include computing the list of operations to be done and actually executing them. So what are the actions? Trigger actions are, they are executed in response to a trigger. We have two default options which are always available unless you change your SetTrigger API to not include those actions or include only one of them, both of them will always be applied and be available. So the first one is called the compute plan action. This uses metrics and the policy framework to figure out the list of collection API commands to execute to get from the current state to the desired state. So in most cases, this is either add replica or move replica. And then the execute plan, so until now we have just computed it. We haven't done anything with it. The execute plan action actually uses those list of operations and executes them in the cluster, ensures that they actually succeed, and no other triggers are run during the time that we are changing the cluster. This is example of node. I think it's like a duplicate slide. Sorry, ignore about that. The other concept is the concept of a trigger listener. So listeners allow you to hook on to triggers and get a callback. So you can use that callback to, maybe just for notification, or maybe you want to provision nodes, or maybe you just want, you want a notification so that an operations person can look at why the node went down in the first place and maybe bring it back up. In the meantime, Solr will continue to move replicas of the old node to the new node, but somebody else can take a look and bring that node back up. So the listeners are attached to life cycles of the trigger. The life cycle includes start, completed successfully, aborted, or failed. You can also listen for the start and finish of each action. So if you want to say, hey, I want to have a listener which tells me once the plan is completed, so maybe I can take a look at the plan, and maybe I can have an option to abort the processing. Or maybe I want to send that as an alert to somebody else, and I don't want Solr to automatically execute those actions. So maybe I'll do that after I inspect them myself, and things like that. In 7.1, we have two new listeners. One is actually default and implicitly added to each trigger. It's called a system log listener. What it does is that, so if in case you're not familiar, there is a .system collection inside Solr Cloud. It is used for blob store. It is also used in this case to store the operations that are performed, the events, their times, the result of those operations, and stuff like that. So I will describe that we actually have, there's a very nice API which tells you the historical actions by looking at this system collection. So you can have a historical view of your cluster as well. The second one is called the HTTP trigger listener. You can add it. Here is an example. You can add it to a particular trigger and get a callback. And it supports template parameters. So you can send the important information from that event either as a parameter, or if you don't specify the parameters or anything like that, the whole list of important properties for that event or for that operation is sent across as a JSON payload to whatever API that you build. So this is the way for you to get a callback. In future, we'll probably have more callbacks. Maybe we can add a JMX listener and stuff like that. But this is what we have today. The other very interesting thing that is added in 7.1 is generally available support for Autoadd replicas. So Solr has had support for this for a long time, but it's been limited to HDFS or shared file systems only. There were a few reasons for that. Let's not get into that. But with this framework coming into the picture, now when you enable Autoadd replicas on any collection, we automatically create the required listeners and the triggers internally. And you can, Solr will strive to maintain the replication factor even if a node goes down. It will just create new replicas on other nodes according to the current policy and preferences. So this is really nice. This is something that a lot of people desired, but it was limited to HDFS users only. Now it is generally available. There are a few more enhancements. There is support for placing replicas based on the type of replicas. So perhaps you want to place your NRT replicas on SSDs, and maybe you want to place the pull replicas on rotational disks or something like that. Maybe you want to place your T-log replicas on faster machines because it's going to do indexing as well as querying, and your query replicas on not so beefy machines. You can place, as I said, we are going to add support in 7.1 for arbitrary metrics in the policies. So you can place replicas based on arbitrary metrics which are exposed by the metrics API. We have a new history API /autoscaling/history. It gives you a very nice historical view of when a node was added, when a node was lost, and what was done in response to those events. So anytime a trigger is activated, anytime actions are executed, it finishes, it fails, whatever, everything is recorded in this system collection, which is used by the history API to give you a JSON response. We also are going, so the history API is already done. Placing replicas based on arbitrary metrics is something which is in progress right now. The autoscaling suggestions API is also something which is planned, not started yet. The idea of the suggestions API is, instead of waiting for a trigger to fire, if you want to invoke this API right now, and if you want to get to know right now what operations should I do to get to a desired state, then you can use this API. So you don't need to have a trigger to get there. You can just invoke this API whenever you want, and Solr will compute what operations are recommended to go to the desired state. So this can be super useful. So the idea is later we can add pages in the admin UI to give you recommendations on, maybe you should be doing this right now to improve your cluster, or maybe this was the historical, events that have happened in this cluster and stuff like that. And then because we have triggers, we also obviously want a way for you to suspend and resume them. Maybe you're going to do some maintenance yourself. You just don't want the Autoadd replicas or other triggers to run, so you can suppress them. So the API is kind of nice. It actually lets you suppress triggers by name, or you can say suppress all of them, or resume all of them, and so on and so forth. So this is what is currently planned or implemented for 7.1. We are hoping that 7.1 will happen pretty soon, because 7.0 took a long time, and we already have a lot of stuff, already committed for 7.1. So my guess is probably within a month you will see a 7.1 coming. So with that, let's go to some of the future work. So this is just a start. Like, we have a lot to do to reach our goals, but these are, this is the framework that we have been putting in place, which will help us get there. There are like plenty of details that I have not told you about. There are like plenty of bugs and problems that we had to fix, APIs that we have to build in order to get here. We had to like add resiliency of actions and triggers against overseer failures and random node failures and stuff like that. So we're not going to go there, but we still need to do a lot more. And some of the examples of those are the search rate trigger. So you can have a trigger based on the QPS. So whenever the QPS spikes and remains there for a long time, you can activate a trigger and maybe add a replicas into your cluster. The search rate trigger, by the way, is already built and done. It's committed to a branch in the Solr code base. Andre has been working on it. We are going to add triggers for disk space, and we are also going to add hints to different APIs. So today, if you add a replica on a particular node, Solr doesn't care that the node doesn't have enough space to add that replica. It tries to do that, and then boom, blows up. We don't want those things to happen ever. Obviously it's a bad experience for the user, but it's a terrible thing to do if you're doing autoscaling. So we want to fix those problems so that they never happen. And there are lots of things we can do. So for example, if you're adding a replica, we know the size of the replica because we have other nodes, right? If you're splitting the shard, we know approximately how much size each subshard would have, and so on and so forth. So we can use those hints inside the policy preferences framework to place replicas accordingly. We're going to add support for disk types, so you can say, right now there are ways to, we are going to expose it in metrics first, but then we are going to add it as a first-class citizen to the policy, so you can just have a simple say, disk type :SSD or disk type :rotational to place replicas. We have plans to add provisioning actions. So if you're running inside AWS or GCP, we'll probably have classes specific to each of those cloud environments. I don't know how many of them we'll cover. Maybe we'll just start with one initially, maybe AWS or something. But the idea is that as part of these actions, if a node goes away, perhaps we can add a new node of a certain type. Again, some of these things can also be done through the autoscaling groups, but if you don't want to mess with that, if you want that whole thing to be happening inside Solr itself, then we can make that possible. We are going to add index rate triggers. So today, there is no support to do automatic shard splitting. That's for a reason, because it's a very expensive operation, and we're not sure if we are there yet to do something like that automatically. So all we do is add replica and move replica, and we prefer move replica more than we prefer add replica. But eventually, we want to have an index rate triggers. So if your indexing rate goes beyond a certain time, we can try to do an offline split on another node so that the load is isolated, and then perhaps we can try to bring that back in and start indexing into subshards and retire the old parent shard. So that would be really cool to have, and that is something that is absolutely required to go to a trillion doc level. So that is actually all that I wanted to cover. Obviously, there are lots of details here. The reference guide for Solr 7.0 is already done. If you look at the draft reference guide, which is generated every day by the Apache Jenkins, then it has documentation for all these features, at least the ones which are releasing in 7.0, and the rest of the things are still being built. Solr's 9735 is the parent Jira issue through which we have been doing all the work. So you'll see like a huge list of subtasks there. Some of them are completed, some of them are planned, some of them are in progress. So if you want to help out with this feature, if you want to contribute, I invite you to take a look at that Jira, maybe take up one of the tasks, or maybe suggest some new tasks that we should be doing that we haven't thought of. So now with that said, let's take some questions. Yes. Right. Yes. Yeah. So the question is, like, can we use the policy to provision nodes as well as to say, add replicas or move replicas or split shards when the replicas go beyond a certain size? Right. Yeah. So absolutely, that is something that we have planned for. So we want to have triggers for the index size. We also want to have triggers for document counts. So when the document count exceeds a certain limit, perhaps you want to do split shard automatically. But again, that requires the split shard to be done first. So we don't have the support for that yet, but that is absolutely something that we plan for. Well, there is nothing that stops you from, so the question is, can you use it for GCP or AWS right now in 7.1 or 7.0? There's nothing which is going to stop you from doing that, but there's no support for provisioning. But like, I attended your talk yesterday, and you talked about how you guys use the GCP autoscaling groups to automatically add replicas. So if you do that, they can automatically be detected by triggers, and then Solr can do the rest. So you don't have to build custom logic to place replicas or add replicas. That part can automatically be handled inside Solr. Yes?
So in order for us to figure out which shard we need to move for, we would have to look at metrics over a period of weeks or some period of time, because we might have a spike in load.
Right.
So is that something that you currently do? Or?
Yeah, so there are two parts to it. So for example, the search rate trigger, it looks at historical information. Right now, I think it looks at the 1 minute queries per second. But it's not configurable today, but perhaps we can make it configurable. The second part is the wait for parameter for the trigger. So that means that if the sustained last 1 minute rates, they are sustained at that level for the next 5 minutes, only then the trigger is going to be activated. So that can help. But we don't look at history beyond that right now. This is something that we might do at some point, but we haven't really planned for that today. Yes? So we have been testing extensively, through integration and unit tests. And Andre has been working on a framework inside Solr, which lets you simulate large number of nodes and real-time clusters faster. And we also plan to do this testing on like AWS and other cloud environments, like on a real cluster. Yes.
So in environments where the heterogeneous characteristics of hosts, would arbitrary metrics help in saying that okay, this has these many processors?
Right. So the question is, in cases where you have heterogeneous hosts in the same cluster, differently powered hosts, how would this work with that? So the answer is yes, metrics will definitely help because these number of CPUs and other things like that are exposed by metrics. And also we have support for system properties. So if you can start those nodes with a system property saying this is a node of type X versus this is a node of type Y, then you can use that information in the policy to place replicas accordingly. Yes? Will there be what? Will there be any downtime while autoscaling? No, we hope not. But all we are doing is basically moving replicas right now, or adding replicas. So we don't think that there's going to be any downtime there. Is there a what? There's no trigger for that, but the diagnostics output will tell you. So I probably skipped over that, but if you look at the diagnostics output, there is an empty parameter attribute here called violations. So the violations at any given time will tell you which nodes are currently violating the constraints that you have specified in the policy. So there is no trigger for that, but if you want to watch for something like that, then that can help tell you that there's probably a node which is over limit right now. Yes.
So if you have, for instance, collections created by an external system, is there a way to apply policies to like a config set? So new collections based on config sets would automatically have policies applied to them?
So the cluster policy is automatically applied to all collections.
Yeah.
But if you want to use collection-specific policies, then there is a parameter that you have to specify as part of the collection creation commands. So it says basically, just like you have name and num shards, and you can say policy equal to the policy name, and then that policy applies. Yes? Well, in future, yes. As I said, we might actually do a JMX listener, which invokes a JMX method. Perhaps the HTTP trigger can be modified, or maybe it's already sufficient enough to do that. Or maybe you can write a shim API for yourself, which gets the response from the HTTP trigger and then further calls your monitoring frameworks. So the framework is still there. It's not complete, but it's we have thought about that basically. Yes. Yeah, so the question is the overseer doing, what is the role of the overseer here? So the overseer is actually the node which runs all the triggers. So the triggers are basically scheduled threads which wake up every 1 second or 2 seconds, and they look at the current state and they see what event has happened in the past. Am I ready to fire something, et cetera, et cetera. So yes, the overseer is doing the bulk of the work here, which basically also means that if the overseer fails and it goes to a new node, we'll continue from where we left off. There are some mechanics around that, but yes, that's the whole idea. Yes? So the question is, when you have Autoadd replicas enabled and you add, so you lost a node and Autoadd replicas is doing something, but then you added a new node to the cluster to replace the old one, what happens? So the answer is, it does not know about that new node, but if you have, so let's say the old node comes back. I think that's the more important question. What happens if the old node comes back? So in Solr, we have a way of replacing cores that have already been moved to new nodes. So when the old node comes back up, it sees that, hey, some new node is supposed to have these cores now. I'm just going to unload them locally. And then if you have a node added trigger also enabled in the policy framework, then you can use that to further add or move replicas to that new node. All right, thank you very much.